In the standard 8.EE.8b, where we are asked to solve systems of two linear equations in two variables algebraically and estimate the solutions by graphing the equations. Well, here we have a system where both equations are in slope-intercept form, so certainly graphing could be a possibility, but if you're not given graph paper or a grid, well, then it may be easier to actually solve the system algebraically. And the way that we're going to do this particular system is we're going to solve this by a method that we call substitution. So let's start by writing our system down in our work area. Okay, first of all, notice that both of these equations, since they're in slope-intercept form, they are both equal to the same variable. They're both equal to y. Well, what that means is that technically then, since they're both equal to the same thing, they must also be equal to each other. So in a situation like this, we could simply take the first equation, the right-hand side of that equation, that expression, and set it equal to the right-hand side, that expression on the other side of the equation. And once again, the only reason that we are able to do this is because both of these are equal to the same thing. They're both equal to this variable y that we don't know what it is, but we know that it's the same variable, so it has to be the same thing. So because of that, we have this type of multi-step equation with variables on both sides of the equation that we have solved many, many times this year. So when I'm solving this from here, I like to get the variables on the left-hand side first. So if we're going to do that, we would have to subtract 3x from both sides. So now on the right-hand side, we have 2x minus 9, and on the left-hand side, we have 2x minus 9. On the right-hand side, we have only 5. And so to finish this off, we would, of course, need to add 9 to both sides. And we have 2x equals 14. And then after dividing both sides by 2, we end up with x equals 7. So we've done that sort of thing many, many times. So we're supposed to write our answer as an ordered pair, because if you think about this, if we were to graph this system, it would end up crossing at one point, and that point is an ordered pair. So right now, since we have a variable, we know the variables are not eliminated, so that means we know part of this answer is 7 comma something. We found the x value of that ordered pair. Now we have to find the y value. Well, as far as how to find that y value, you can either take this, I didn't mean to use the eraser, we can take this original equation or this original one and replace x with 7 to figure out what y is. It doesn't matter which one. I'll go with the second one. Y equals 3x plus 5, and I am going to replace x with 7. So we've got y equals 3 times 7 plus 5, and so we've got y equals 21 plus 5, and so y has to be 26. So this is a perfect example of why sometimes graphing is not necessarily the best method. Because think about this. If we actually graphed this system, those two lines would end up intersecting or crossing each other at 7 comma 26. Most of the grids that we have just go from negative 10 to positive 10. So clearly that would be way off of the grid. And this is just one example why we need other methods, algebraic methods, to sometimes solve systems of equations. In the standard 8.EE.8b, where we are asked to solve systems of two linear equations in two variables algebraically and estimate the solutions by graphing the equations. Well, here we have a situation that compares Chris's surfboard rental versus Braden's surfboard rental. Chris's situation is represented by the blue graph, and Braden's is represented by the red graph. And once again, we're comparing the rent paid in dollars. You can see that by the label on the y-axis or the vertical axis. And we're comparing that to the number of hours that they used the board or they rented the board. And we can tell that by the label on the x-axis or the horizontal axis. So there are several ways that we could attempt this problem. We can clearly see that those lines are going to eventually intersect each other. The question is where? Well, I suppose we could guess, but it would just be exactly that. It would be a guess. And remember, when we're finding the solution to a system of equations graphically, we are trying to figure out where those two lines intersect each other. A different method would be by using an algebraic method called the substitution method. So in order to do that, we would need to find the equation of the line that represents Chris and compare that to the line that represents Braden's line. So let's go ahead and do that. So Chris's line, we can see, has a y-intercept of 6. And I'll find another perfect ordered pair so I can see there's a rise of 3 and a run of 2. So what that means is that Chris, his equation is y equals 3/2 x plus 6. As far as Braden goes, he has a y-intercept of 3. I'll find another perfect ordered pair. And considering rise and run to figure out what the slope is, I can see that the slope is 2. So as far as Braden goes, we have an equation of y equals 2x plus 3 because Braden's line has a slope of 2 and a y-intercept of 3. So as we learned earlier, since we have both equations that are equal to the same variable or y, what that means is that we can take those expressions and set them equal to each other and then solve that equation. So we have 3/2 x plus 6 equals 2x plus 3. So I like to get the variables on the left-hand side. So if I'm solving this, I would subtract 2x from both sides. And when I do that, 3/2 x minus 2x is negative 1/2 x. And I am kind of running out of room here, so I'm going to come up here. I have negative 1/2 x plus 6 equals 3. So I would subtract 6 from both sides. I have negative 1/2 x equals negative 3. And of course, I need to divide both sides by negative 1/2. And I end up with x equals, that ends up being 6. So since the x-axis represents hours, that means after how many hours would they have this? Would they have paid the same amount? That would be 6 hours. Now the question is the cost. Well, these two lines are going to end up crossing each other right there at 6. It looks like it's maybe around $14, $14, but I really have to be certain. So in previous problems, we would take either Chris's original equation or Braden's original equation and replace x with 6. I'm going to go with Braden simply because it looks like it's easier to deal with. And once again, I'm going to replace x with what I just got, which was 6. And I get y equals 12 plus 3. And it had looked like it was going to cross at 14, but it's actually 15. And this is why, in many situations, using this method that we call the substitution method may be the best option. In the standard 8.EE.8b, we are asked to solve systems of two linear equations in two variables algebraically and to possibly estimate those solutions by graphing. Well, when I look at this system, graphing does not really appeal to me. So algebraically definitely probably is the best scenario here. So notice that we have one equation in standard form, the top equation, and the other one in slope-intercept form. Well, at this point, we have already learned the elimination method, so I'm going to want to use the elimination method because I believe that that is probably, in the grand scheme of things, maybe the easiest way to do this. So what we will need to do, the first equation is already in the standard form that we need it to do the elimination method. This equation right here, we need to put it in standard form. So if we subtracted x from both sides, it would then be in standard form. So that would give us negative x plus y equals 15. So remember, the idea behind the elimination method is I need to somehow eliminate one of the variables. In my opinion, the easiest way to do that is to multiply only the bottom equation by positive 7. So watch what happens when I do that. This second equation now really is equivalent to negative 7x minus 7y, or plus 7y, excuse me, equals 105. So what that really means is that this has now become that. So now we're dealing with this equation and this equation. So now if we add straight down, we can see we've got negative 4x and negative 7x, that's negative 11x. The y's are eliminated. As far as the constants go, we've got negative 28 and positive 105. That makes positive 77. And now if we finish solving x, we get clearly x equals negative 7. So we now know we have one solution, and we know the x part of that solution is negative 7. From here, we take either one of the original two equations and replace x with 7. Clearly, the second one, the original second one, is the easier of those. So I'm going to replace x with, and I did not mean to write 115, I meant to write 15. I'm going to replace x with negative 7, so I have y equals negative 7 plus 15, and that is y equals 8. And so now we have our solution to that system.